Hey students, we're looking at definition of derivative and derivative rules for the first section of our Spiral 8 review. In terms of what's going on here, we're going to be looking at some basic derivative rules and some derivative by definition. First thing that we're looking at here, so this is a derivative by definition, and that's something that we're going to have to begin to recognize. I'd like us to notice that this is the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the derivative. And this is when x equals 2. So here's the thing. If this is the derivative when x equals 2, what this tells us is that the derivative exists when x equals 2. In fact, it has a value of 5. For a derivative to exist, it's got to be differentiable. For it to be differentiable, it has to be continuous. We don't necessarily need the derivative to be continuous at x equals 2. There are some cases where that might not happen. That's a little bit weird in terms of trying to talk about that, so we can also use some kind of cheating methods to look at our answers. We know it can't be 1 or 2 because 1 and 2 have to be true. D is 1 and 3 only, but we don't have 2 there, and E is 2 and 3 only. So by elimination, we can kind of determine that 3 is not necessarily true because it doesn't fit any of those answers. For number 18, we're trying to find f of 1.2 found by using the line tangent to the graph when x equals 1. We're given the derivative and we're given the value for this. This idea is that if I know that we have a point 1, 4, and if I know the tangent line, which in this case is going to be something like this, we can use that to approximate a value pretty close to there. So this is going to be a multi-step thing. We're going to have f prime of 1, because we want that tangent line. And that's going to be 2 times 1 plus 1, which is going to be 3. So our tangent line would end up being y is equal to, in this case we are using the point, 4 plus my slope of 3 and x minus 1. For 1.2, because we're trying to find it really close to this point, I'm going to plug 1.2 in here. We get y is equal to 4 plus 3. 1.2 minus 1 is going to be 0.2. 3 times 0.2 is 0.6, and we get 4.6 as that value. Okay, kind of similar to the first one, this is another definition derivative, and just so we can see what's going on here, f of x plus h minus f of x. First thing I notice is that instead of x's I have 4's, so x is going to be equal to 4, and f of x is going to be ln of x, if I kind of back substitute that. I notice that because I've got ln of 4 there and ln of 4 plus h, so ln of x plus h and ln of x. This means the derivative of ln of x, and then plugging in x equals 4. We know the derivative of ln of x is 1 over x, and 1 over x, when you plug in 4, is going to be 1 over 4, which is b. All right, at what point on the graph of y equals 1/2 x squared is the tangent line, so I know I need a derivative. Y prime is equal to, that's going to be 2x. And parallel to the line 2x minus 4y is equal to 3. Let's put this in slope-intercept form so we can see the slope more easily. And that's going to be negative y is equal to negative 2 divided by negative 4 is 1/2 x, and then that would be 3 divided by negative 4 is minus 3/4. The only part I really care about is that slope, because the slope is what we're looking for here. So if this is 2x is equal to a half, that means that x is equal to a fourth. Which happens in none of those problems, and that's because I can't math today. And if I take the derivative here, we have 2x times a half because of that 1/2 out front, which just is x and not 2x. So if x is a half, that means that x would be a half here as well. And now we've got 2 possible options. So what point on the graph? Let's plug that point in. So 1/2 times 1/2 squared is going to be 1/8, which is B. Last problem, f of 3 is 2, f prime of 3 is 5. Okay, just to kind of figure out what's going on, f of 3 is 2. That means 3 comma 2. F prime of 3 is 5. That means I've got a slope of 5 for my tangent line there. If the tangent line is used to find the approximation to a 0 of f, that approximation is, that's a messy thing. So 0 of f means when f of x is equal to 0. So we're looking for a height of 0. Okay, let's write my equation for the tangent line and try to make some sense of this. So y is equal to 2 plus 5, and that's going to be x minus 3. To approximate a 0, we're going to say 0 is equal to 2 plus, I might do some distribution now, 5x minus 15. Bring everything to the other side, and we get 13 plus 5x, or is equal to 5x rather, and 13 over 5 is equal to x. 13 over 5 is going to be 2.6, which happens to be C. That's kind of a rough way to interpret that. So just kind of backing through that, we had to find the tangent line to the graph. That's what this guy was. And then we had to find an approximation to a 0. That's what told me that y had to be 0 there. So they're asking us to use the tangent line to plug in y equals 0 and then solve from there. We've got trig derivatives and chain rule. First thing I might do is to rewrite this as cosine of x cubed squared, so that I can see that I've got chain rule to start this out. And we've got 2 cosine of x cubed, and then multiply that by the derivative of cosine of x cubed, which would be sine of x cubed. And then I'm going to multiply that by the derivative of x cubed, which would be times 3x squared. So I've got 6 in total for 2 times 3. And they put x first, so I'll do x squared cosine x cubed sine x cubed, which happens to be choice A. For number 6, we've got a lovely product rule going on. It's going to involve a chain as part of that. So we've got a first and second function. Second function, x plus 1 times the derivative of the first, which is going to be 5 times 2x minus 1 to the fourth times 2 for the derivative of the inside, plus the first, 2x minus 1 to the fifth times the derivative of the second, 1. And then we got to plug in x equals 1. So 1 plus 1 would be 2 times 5. 2 minus 1 would be 1 to the fourth. That's nice. Times 2. And then 2 minus 1 is going to be 1 to the fifth, and then 1. Okay. 2 times 5 times 1 times 2 is going to be 20. And 1 times 1 is going to be 1. So my slope is going to be 21. That eliminates 3 of my 5 answers. And then finding the value of the y-intercept, let's plug in. So in terms of looking at this, plugging 1 in, sorry if there's some jumpy stuff in the recording. I overwrote some stuff and messed some things up. We're going to have 2 times 1 is 2 minus 1 to the 5th. And then 1 plus 1 is 2. So that's going to be 1 times 2 is 2. That means that my point is going to be 1 comma 2. So in terms of this, it's going to be y is equal to 2. We got to use point slope form. Plus 21. And that's going to be x and minus 1. These are in mx plus b, so it might be nice if I actually combine some things. We get 21x minus 21, which is going to be minus 19. Woo! We've also got some implicit differentiation in exponentials and logs. Let's start off with number 40 for some reason, which is the tangent of xy is equal to x. And when I go and take the derivative of this, I know this is going to be, the derivative of tangent is going to be secant squared of xy. And then that's going to be multiplied by the derivative of xy. This is going to be so lovely in just a minute. And the derivative of x is just 1. Okay, the derivative of xy, that's a product rule. You know, before I do that, I'm going to divide by secant squared of xy because I don't feel like dealing with that. So the derivative of xy is going to be 1 over secant squared xy, which is the same as cosine squared xy. The derivative of xy is going to be y plus xy prime. That's cosine squared of xy. And just so that you don't get confused about where that came from, 1 over secant of x is the same as cosine of x. That's why I just switched it there so we wouldn't have a fraction. And then if we do that as minus y, cool. And then divide by x, we end up with something that looks like this. And I have a feeling that this is gonna be, oh good, it is one of the answers. I was worried they were gonna make us do some more algebra to get there. For number 17, we're taking the second derivative. That's what this notation means. And this is going to be kind of fun as well. So we're going to start off with the first derivative, which would be 2x plus 2y y prime is equal to 0. And to get the y prime by itself, we end up with y prime is equal to negative 2x divided by 2y, which is negative x over y. Okay, the second derivative, so y double prime is equal to the derivative of negative x over y, which is a quotient rule. That's going to be the bottom times the derivative of the top, which is negative 1, minus the top, negative x times the derivative of the bottom, y prime, all over the bottom squared, so y squared. And here we have a weird thing happening, which is that we have a y prime in here. The good thing is we have y prime defined as negative x over y. So one of the things that we can do is to figure out what this is by doing something like, okay, so negative y plus xy prime over y squared. And if I'm using the point 4 comma 3, that would be negative 3 plus 4y prime divided by, and that's going to be 3 squared is 9. Y prime at those same points, 4 comma 3, would be negative 4 over 3. So if I plug that in, we get negative 3 plus 4 times negative 4 over 3, all divided by 9. which is going to come out as negative 16 over 3 minus another 9 over 3, which would be negative 25 over 3, and then divided by 9 is going to be negative 25 over 27, which happens to be A. For number 9, we've got to take the derivative of a natural log of stuff. We know that that's going to be 1 over stuff, and we've got a lot of stuff going on here. X plus 4 plus e to the negative 3x. And then we're going to multiply that by the derivative of that stuff, which would be 1 plus 0 plus e to the negative 3x, and then times negative 3, because it's derivative of e to the stuff is e to the stuff times the derivative of the stuff. We had a double chain rule in that problem kind of hiding there. F prime of 0, I'm going to plug 0 in everywhere. So let's write this, and we do 1 over, well, it's going to be 0 plus 4, and then e to the 0 is 1, and that's times 1 plus e to the 0 is 1 times negative 3. So that'd be negative 3 plus 1 is negative 2, and 5 on the bottom, which is A. For looking at number 10, if you happen to remember your non-e-log rules, which I never do, you could do that substitution there. It's probably the shortest way to do this. So I'm going to pretend that I know this off the top of my head, and that's totally fine. And I'm probably going to get this very wrong, like 2 seconds, because I always forget these. So that would be ln 10 times 10 to the stuff, and then that's probably times the derivative of that stuff, so probably times the derivative of 2x. And if I look for there, that looks like option D. If for some reason you don't remember these things, you want to convert this to another form, you can deal with that with logs, but I think that's probably good enough for us. Yay, I did it right. Thank you to Julian for letting me look at his derivative rules to live by sheet to make sure that I actually looked at this and did it correctly, because I never remember. Next up, we've got RAM and the integrals area. We get to have some fun with some notation here, since we didn't get to talk about that in class. But that's okay. Big idea is, if we're looking for the total number of barrels of oil, and we're dealing with barrels per hour and hours, you might think about this as an accumulation, aka an area problem. What we're trying to figure out is the area of all of this stuff together. And kind of the easiest way to take a look at that might be to divide this into a rectangle and a couple of triangles. This is not quite using some kind of RAM, rectangular approximation method, but this is a way that will definitely work for us. So we've got 24 times 100, that'd be 2400 for this entire thing. And then each of these triangles, if I put them together, that would make a full rectangle going on, and that would be 6 wide and 100 tall, so that would be plus another 600. And that's basically it. So 2400 plus 600 would be 3000. For number 10, we have this new notation that we haven't really talked about. And in terms of this notation, which is something we call an integral, means the area under this graph between 1 and 3. So in other words, if I were to find this, the exact amount would be that area. And we said that would be like a limit if we wanted to get smaller and smaller rectangles. And this is the notation for that. We're going to see this a lot over the coming weeks. A left Riemann sum with 4 subintervals, okay? So that would be starting from the left side, and look something like this. And the first thing that you need to know is that these are all bigger than the actual value. So if this is the actual value, left Riemann sum would be bigger. So I'm going to say that this is B is greater than A, just to kind of get that thing started. Okay, let's erase some stuff and go back at this. So again, if we're looking at this area, a right Riemann sum with 4 subintervals would all be sitting below the curve because these are all on a decreasing function. So to me that means that C is going to be less than A because A is the actual amount. So right now in terms of size values, I've got B is the biggest, and then A, and then C, and maybe D will fit somewhere in there, or E will fit somewhere in there. Okay, let's erase some stuff again and go back in. Using midpoints, and for midpoints we're looking at values that are in the middle of these intervals, so we'd end up somewhere in between our values so far. I know that's not going to be bigger than B, and I know that's not going to be smaller than C, since those are kind of, it's going to be exactly between those, or somewhere between those. And simply for the one that has the least value, which right now C is winning, I can ignore that. And finally, looking at a trapezoidal sum, if we take a look at these values, so we're looking here, here, and then the points in between there. The trapezoids are going to connect these as close as possible. And that's actually pretty close to the option for A. It's not going to be exact. I don't know why I just circled that, so I'm going to erase that circle so it doesn't get confusing. But that's going to be really close to the actual value because they're kind of brushing along the curve there. It's going to be a little bit under the curve, and that's because this whole curve is concave down. But we're not really going to worry about that because, again, if it's just about the same as option A, and D was pretty close to that too, we're looking for the one that's the smallest, the least value, which is going to be option C. And that was because the right sides of these are all pretty far below the curve. So when you find these rectangles, they'll all be less than the actual value. And just again about this notation, this talks about the area under the curve between x equals 1 and x equals 3.